Hello and welcome back to the channel everyone. In this playlist, we will be covering the concept of sorting. A sorting algorithm is used to rearrange the elements of a list based on a predefined condition. For instance, let's say that we have a list of numbers and the list is 5, 4, 8, 3, 2. Now if we have to arrange this list in descending order, we will pass the list to our sorting algorithm and the output will be a list sorted in descending order or the elements arranged in descending order, and the output would look something like this. Sorting does not necessarily mean arranging based on magnitude. For example, let's say that we have a list something like -1, 5, 8, -2, 3, 4. Now we want a sorting algorithm to work in such a way so that all the negatives are in the front and all the positives are behind the negatives. So when we pass this to our sorting algorithm, the output would look something like this: -1, -2, 5, 8, 3, 4. So based on our defined condition, this list has been sorted. All the negatives are ahead of all the positives. Now, there could have been multiple possibilities. There are different possible outputs for this particular problem. So, -2, -1, 5, 8, 3, 4, or -1, -2, 3, 4, 5, 8 are all acceptable outputs because in all these outputs, the negatives are ahead of positives. Similarly, if we have a list of strings, we can say that we want to arrange them lexicographically. And our sorting algorithm should output a list with strings in lexicographical order. Now, there are certain standard algorithms for sorting. Some of these standard algorithms are bubble sort, selection sort, insertion sort. Then we have merge sort, quick sort, heap sort. Then we have counting, bucket, radix. So we have a lot of different kind of algorithms. In most situations, we will be able to use these standard algorithms. In some rare situations, we might have to modify these a bit, or in very rare situation, we might have to come up with a custom sorting algorithm. All these sorting algorithms perform more or less the same task. Just the technique of achieving the defined order in a list is different. So how do we decide which algorithm to pick? There are certain criterias which we can consider. Like first is the use case. Some algorithms like radix sort, bucket sort, counting sort have very specific use case. So when we are working on those use case or our conditions are meeting the prerequisites for these algorithms, then we would pick these algorithms. Otherwise, we would pick the more standard or the more general algorithms from these. We will discuss all these in detail when we pick each sorting algorithm and discuss the prerequisites, pros and cons. Another consideration can be the time complexity. All these algorithms have varying time complexity owing to the different technique being used to sort. Now, for example, bubble, selection, insertion are big O of n square on average, while merge, quick, heap sort are n log n. Count, bucket, radix, these are big O of n time complexity. Then another consideration can be, is it a in-place algorithm? So in-place algorithms are the ones that do not require any extra additional helper space. So if we have space constraints, then we would like to pick a sorting algorithm which is in place. Another factor is it a stable sort algorithm? Now what do I mean by this is that if the similar elements in the array maintain their original relative ordering in the output sorted array as well, then it is a stable sort. Let's understand with an example. Let's say that we had an array 6, 6, 2, 1, 4. Now let's also assign each element their current index. So this is 6, 0. The second element is representing the index. This is 6, 1. This is 2, 3. This is 1, 4. And this is 4, 5. Now let's pass this to our sorting algorithm. And if the output looks something like this, 1 comma 4, 2 comma 3, 4 comma 5, 6 comma 0, and 6 comma 1, then the sorting algorithm is a stable sorting algorithm because this array is sorted. 1 is ahead of 2, 2 is ahead of 4. So the elements are sorted in ascending order of their magnitude, which is correct. And also the relative position of the similar elements is maintained. So 6 comma 0 was ahead of 6 comma 1 originally, obviously because 0 is ahead of 1 index. But if the output was something like 1 comma 4, 2 comma 3, 4 comma 5, 6 comma 1, and then 6 comma 0. Now this is also a correct output because the elements are actually sorted by their magnitude and they are sorted in ascending order. So the sorting algorithm is working correct. But the equal elements have not maintained their original relative position. 6 comma 1 is ahead of 6 comma 0 now in the sorted array. So even though this is the correct output, this is not a stable sorting algorithm because the elements have shifted from the elements have not maintained their relative position as it was originally. So now that we have discussed the basics of sorting, in the upcoming videos we are going to pick each algorithm one by one and discuss it in detail. We are going to discuss the technique used for the sorting algorithm, the logic behind using that technique, the pros and cons of that algorithm, and the implementation of that algorithm. All the factors that we just mentioned, we are going to pick each factor and discuss it in reference to that particular algorithm. So it will be pretty clear that how do we decide which algorithm to pick in which situation. So hope to see you in the next video. Till then, stay safe and keep learning. Bye bye.